Awesome. So we're going to continue with the theme of the integrated assessment, and we're going to finish off right before lunch with a great talk on kind of things going on at the states-wide scale in terms of the healthy watersheds work that's gone on at the state scale. The next few talks are going to focus more on things that are happening at the regional level and some examples of projects we're looking at integration at the regional level. So our first speaker is Karen Worcester. I would butcher your name, I'm so sorry, Karen, from the Central Coast, and she's going to talk about the work that they've been doing.
Thank you, Eric. Let's see. Okay, I'm going to talk about a project we've been involved with in the Central Coast for about the last 3 years or so, and I would like Dave Paradis to stand up in the audience. I was going to say he's the bearded guy, but then I realized that he has company in this crowd. So. At any rate, Dave has done all the software development for this project and a lot of the brain power as well. And so, with no further ado, this got started when our region went through a visioning process and came up with a somewhat coincidental vision of healthy watersheds in retrospect. And that involved 3 goals that we developed related to healthy aquatic habitat, proper land management, and clean groundwater. And today, I'm just going to focus on the aquatic life goal, for obvious reasons. But basically, all of them are set up this way where we're looking to see that 80%, in our region, 80% is healthy, and the remaining 20% is improving. So all of the goals imply that we need to assess health, assess status, as well as a trend component. So Dave and I undertook the work for this project with the idea that we would integrate. We have a fairly robust monitoring program in our region called the Central Coast Ambient Monitoring Program with a lot of different data types. So we wanted to make use of multiple data types and roll them into a report card that was readily accessible and user-friendly. We also felt we needed to integrate our site level data up into more of a spatial assessment of whole watersheds in order to address the goal. And third, like I mentioned, we wanted to integrate trends, and we wanted to not only do it in individual parameters, but also at the scale of indices and spatial areas. I don't think I'm going to have time to talk about trends today, but if anyone is interested in how we did that, I actually have a few slides. We can talk about it some other time. I'll start with talking about integration of multiple data types into our watershed report card. So we've done a lot, because I've worked with Dave for years, we've done a lot of work in a web environment, and that was something we really wanted to make sure we incorporated. We wanted to use data that was readily available online from our major data sources like SWRCB or CDN. We wanted the software to basically update the website routinely. We didn't want to have to go through a big laborious process to update our scoring. We wanted to develop a relatively consistent scoring approach that we could use across multiple parameters that's based on selection of a single threshold. And in selecting those thresholds, and also another thing I'm not talking about is our very large compilation of thresholds that we've pulled together from multiple sources. We were looking to identify measures of health, not harm. A lot of, for example, chemical parameters are set based on toxicity. So we wanted to select ones that were conservative in terms of protecting for health. And then we wanted to set up an environment where you could drill down for detail from a broad report card page down into the level of the analyte. So this is a screenshot from the Healthy Watersheds web report card. And I'm going to go through a series of slides that are not yet online, but we hope will be online maybe in the by this spring. So it's not available yet, but It does actually work in the web environment. I'm not staging this. So basically it comes up with a map that's color scored by polygons as to a report card grade. In this case, this is aquatic life. And what you're looking at in these bars here, the first one's for aquatic life and the second is for human health, right now represents % of our sites and how they have scored. But the process that I'm going to describe to you is, that we're involved in right now, is translating that into % of area. So ultimately that will represent % of area. So these are actual scores of our sites. And right now, at this point in time, we only have the 2 human health and aquatic life goals represented. We'll be working on the land management one in the future. So, because I'm talking about aquatic life today, I'm going to look at, this is a list of the hydrologic units down below in our region with their site scores, basically. I'm going to go to the Santa Cruz hydrologic unit, which is a relatively healthy area with the majority of our sites scoring fair or better. But you can see we have some that are heavily ag dominated, like the Santa Maria or Salinas rivers, that have quite a lot of problems. So moving to the Santa Cruz hydrologic unit, the list of water bodies that we have sample data in pops up, and our grades and the actual numeric score associated with that grade. And of course, the reason I like this example is there's such a standout here. We have one creek that's popping out in the red. You can see the map is zoomed to the Santa Cruz area. Most of our sites are in good condition, but there's that same red site. So if I want to go to that site, that's Gazos Creek in northern Santa Cruz County. You would get a list of the sites that were sampled in that creek. In this case, we only have one site. So that's right at just above Highway 1 at the lagoon. And it scored poorly. So, wanting to drill in further to understand why it scored poorly, you get to the site report card. And this basically shows the various sub-indices that make up our aquatic life and human health goals or indices. So in this case, we have conventional analytes, biostimulation, benthic invertebrates, toxicity, metals, organic chemicals, and hydrocarbons. And it's in the organic chemical sub-index that we're seeing a problem. And when we click on that further, it brings up the chemical list, some summary statistics on the data here. And you can see it's a DDT problem in that creek that's causing the problem. Ultimately, we would like to also connect this report card to our existing data navigator, which has been online for quite some time, that gives you time series access to the data, as well as some statistical analyses for trends and other more detailed information. But the intent of the report card is to really serve more of a general audience where you can look at a level of detail as high as you want, and then you can ultimately drill into something at a much higher level like this. This is nitrate at San Simeon Creek in San Luis Obispo County. Was not doing well. You might want to note over here are little icons. This is a downward pointing arrow, getting worse, and we use that icon on both of our websites for a change. Okay, so I'm going to talk a bit about the scoring approach. You'll find that the talks before lunch just set me up perfectly. We've had to think about so many of the things that were discussed earlier today. So trying to decide how to score data, and like I said, we want to use essentially a relatively consistent approach for the majority of our data. You can't do everything the same way, but we selected we've ended up adapting an approach from the Canadian Water Quality Index, which you'll often hear referred to as the CCME, which actually stands for the Canadian Council of Ministers for the Environment. But we've modified it quite a bit to suit our purposes more, which have a lot to do with wanting to measure health as opposed to harm. and also our desire to be able to drill down and score all the way down to the level of the analyte. But we followed essentially the same report card paradigm they do, and this grading system is essentially the same one that they use, but we've established an additional category for outstanding waters, which is only we use at the index level, so we're looking for high scores across all of our measurements, not just a single measurement. So then we are designating the outstanding waters or blue water streams with the idea of maybe affording them special protections at some point, perhaps. The Canadian approach basically scores, I'm not going to go into high-level detail here, but it combines 3 factors. And the first is called scope, and it looks at what percent of the variables that you're measuring are failing, meaning exceeding a threshold. The second one is what percent of the tests, the individual tests you've taken to fail. And the third one is, they call amplitude. What's the magnitude of those failed tests? So they basically divide the failed tests into the threshold. So you notice it's really oriented towards the tests that fail. So one of the first modifications we do is we score all of our tests, not just failed tests, because we wanted to get better differentiation at the good end of the scale. We wanted to be able to distinguish excellent from good, not just good enough. We actually eliminated the scope term. We felt it was sort of chunky in nature, and actually the authors of the index also weren't overly fond of it, so we felt justified in doing that. And it also aided us in being able to aggregate down all the way down to the level of, score all the way down to the level of the analyte, because the scope term that they use scores across analytes, so it doesn't provide you a grade score at the level of an analyte, and that was important for our web approach. And we do some special handling of some variables, like double-ended variables like pH. One thing I spent quite a bit of time on was comparing this scoring approach and also those report card breakpoints to an existing scoring approach we'd used for a number of years on a previous website. Because who's to say those breakpoints are the right breakpoints, right? Just because Canada used them, especially after we modified their index. So there's something magical about them. I don't know what it is, but I think hundreds of years of grade school teachers had it right in setting up their scoring approach, because it's very similar to the ABCDF scores used by typical grading curve. But the comparison here is 4 different analytes. In the red bar is the old scoring approach, and the blue bar is our new scoring approach. We were just looking at how many grade categories we had using the different approaches. And we actually had, some analytes didn't do as well as these. These performed very well. Pretty good correlation. And the other scoring approach was entirely different. The way we set it up, it used multiple thresholds instead of one. So this helped us validate it, as we just did a lot of best professional judgment reality testing. Does this group of scores make sense being scored, fair, good, or so forth. So we feel very comfortable with where those breakpoints ended up falling. And in fact, I did them independent from the Canadian approach, and they were so close in the end to the Canadian approach, I ended up just using the Canadian approach. So this is nitrate, for instance, in our region. Our regional maps look like for any number of analytes that we've collected data on where we have a red through green scoring approach. So then we combined those measures into, in this case, an aquatic life index, and I already mentioned we have a number of sub-indices. You notice this one includes habitat. We didn't have that on our original web design. That was a mistake. These are the, I won't read them all, but the analytes that are currently in our various metrics. You can see we have basically a set suite for some of our sub-indices, like conventional water quality, but for things like pesticides, basically if we have an acceptable threshold and we've measured that pesticide, we go ahead and score it. There's a couple of unusual ones. These are model outputs from the numeric nutrient endpoint predictor tool. Can you read them in the back? Okay. We're still working on developing our biological and habitat indices, and just recently got our CSCI scores working for us, so that's really great. And I'll show you a little of that data later. We don't collect some of the really diverse biological indicators that Brock was talking about, like some fish and amphibians, for instance. Wish we did, and we would love to incorporate it here, and I think we could if we had a scoring approach for it. But right now, we've just begun collecting in the last several years algae data, so we should be able to add those into the report card soon. In terms of habitat, I'm going to let Ross Clark talk about that next time, because he and Kevin O'Connor are working with us on a project to develop a riparian scoring approach that they will talk about in more detail. The idea being, well, we do have CRAM data in our region, and we do have PHAB data, but we're interested in getting a linear scoring approach that can help us with understanding health of larger spatial areas. So the aggregation issue is really challenging, and as you heard earlier, there's a lot to think about. And what we have been doing at this point is, at the level of the sub-index, we're using different approaches depending on the nature of the data. So for example, for our conventional water quality parameters, we're using a simple arithmetic mean. But for example, with organic chemicals, if you just take a mean of 40 chemicals where 39 of them are non-detects and one's super toxic, you're gonna wash out your signal. So actually with organic chemicals right now, we're using our worst score to be the score of the index. And we're using a geometric mean is useful if you want to emphasize lower scores. So you use, it's a little bit of, it's different than an arithmetic mean in that it emphasizes poorer scoring analytes. So we've been looking at that for scoring our metals. We're still in development with how we're going to roll these together at the level of the index, but we're looking at either a geomean or a weighted mean. Because, you know, I do feel, for example, that biological measures are integrating health in themselves, so we might want to weight our biological measures more heavily. Then there's also existing scoring systems that for data that we all might want to roll into our system. For example, the Southern California IDI that already has, in this case, sort of a quantile approach to scoring 20, 40, 60, 80, 100. So we're looked at ways to map those into our same scoring breakdowns so that we can evaluate them on sort of equal footing with other data. So this is just a visual to help you understand how you would translate scores into the scoring approach we're using. I just put this graphic together really recently, and this was kind of remarkable for me. So this is the California Stream Condition Index scoring breakpoints for likely intact, possibly intact, likely altered, and very likely altered. Shown against our breakpoints, which are also the same as the Canadian breakpoints. And you can see that they're, just with a little wiggle room, they're almost identical. We have two additional categories, the outstanding and the severely impacted. And Pete's using a lot more careful language than we are. I could probably learn something from that, but he's saying likely intact, we're saying outstanding. But nevertheless, it's really, I talked to Pete about it, and he said, no, he just looked at the math, that's how he determined where his breakpoints were going to be, and I'm like, it's uncanny that they're almost the same numbers. So within just a few tenths, so that also was very validating. Like I said, I think there's something magical about the distribution. Okay, the second thing I wanted to talk about is integrating this site level data into a spatial assessment of whole watersheds once you've scored a site for health. So our idea was to take, because we have a lot of data in our region, we want to make use of our measured data, but we also have a lot of areas we don't monitor. We use a targeted design. We're down mostly in the areas that are readily accessible along major tributaries and so forth. So we wanted to take that measured data and overlay it on top of model data. And then use the NHD Plus stream network to sort of move those site scores upstream into the upstream reaches, and use land use boundaries to help define how far we let those scores go upstream. And then where we have no scoring of our own, we use the model data. So the model data we're using, you just heard about in Pete's talk, which is the California Healthy Watersheds Assessment Project. I'm going to call it CADMAS. They're the consulting company that did a lot of the work, but it's short. So this is their map of the California Stream Health Index. That includes physical, biological, and water quality data layers. So we just rashly took that data and applied this stoplight paradigm to it, which really changes the way you react to it. It's odd how much the color scheme changes your impression of the information. But so our region, this is basically the big blob, the big red blob obviously is the Central Valley. And our region is pretty much, everything from there and west. But you can see the Salinas Valley, which is our big, lettuce bowl of the nation, popping out in red. And this is the Santa Maria Valley where we have a lot of ag as well. And this is the Big Sur coastline where we have relatively pristine watersheds. And mostly those colors look about right for those major features. And when you put, this is the actual, our monitoring sites in our region for, that we have data for CSCI. So you can see, maybe, that we have a reasonable overlay of red sites on top of these pink areas and, green sites on top of these blue and green areas. So in the bigger picture, it looks like it's working pretty well, the modeled data in our region. And actually, we were happy to see that when we first put that together. There may be a tiny bit of circularity here in that there are CSCI bug scores going into the model of the CADMAS data layer. But this is actual site data, and that's all been modeled, and it has many other measurements in it, so it was a useful look at it. But when you get up close, this is the Santa Cruz area. We started seeing a lot more dark red where we just didn't think things were that poor. We see a lot of, I would say, far more poor scoring areas than our actual data probably will show. In particular, we're seeing it along the coastline where we might have little small coastal streams coming in, and a lot of these coastal areas are showing as red. And so that, we're going to look into this in more detail and see why they're scoring that way. But it's definitely something that we're hoping our data is going to help improve. And in fact, Dave has just now, in this last week, been working on doing the connectivity between our site scores and the upstream reaches. And you can see how in this first cut, we're seeing a lot more good scoring sites. This is sort of the San Lorenzo River area in Santa Cruz. When I'd say that's more accurate, I think we have some reasonable quality streams in here. The good thing is when you can't see the stream, it means it's a perfect overlay. So for example, that's yellow on yellow, green on green, and here, red on red. But there's definitely some mismatches, and so we'll be working on how to match these two layers together in more detail in future weeks, months. And just to close, this is our, again, a little bit circular, but this is our measured bug sites in our region, the CSCI scores on the x-axis against the stream health score from Cadmus. And you can see, yeah, there's a relationship there, but it's not a particularly tight relationship. So I think what we'd like to do is exactly what Pete was mentioning when he closed, which was look to customize that, you know, our use of those layers, and perhaps see if we can tighten up without going circular, tighten up a relationship so we have better confidence in the model data, that it's a good reflection of what we think our regional health looks like. So that's where we're at right now. We're hoping to have this report card ready for release this spring. That may be optimistic, but at least, you know, that's what we're striving for. And we've also been having some great dialogues, for example, with the state's Healthy Streams work group for the My Water Quality Portal, about possibly adapting some of this use at a wider geographic scale. So we're in dialogues about that as well. So that's it. Thank you.
Time for a question or two for Lori? And for Karen, I'm looking at Lori. Push your last name and your first name. Question for Karen.
Hey Karen. I was wondering, the stream condition index, those are the uncorrected Cadmus scores?
Yes,
Okay.
yes.
So there's a relative, your CSCI measurements are closer to a real,
They're the actual, yeah.
so you might expect there to be a relationship that's present somehow. So maybe a rank correlation or something would tell you more than a direct linear regression, which assumes they're on the same scale. Well,
Okay.
it seems that they're more on the same.
We'll look at that. Thank you. Yeah.
Karen?
Anything else?